Okay, question 11. So here we have a diagram. It shows the network of roads in a small village. The weights are the distances of each road, and the letters are the junctions. So to get from junction A to junction B, it's 56 meters. Musab is required to deliver leaflets to every house on each road. He wishes to minimize his total distance, right? So this, guys, is the Chinese postman problem. It's literally, this guy is a postman because he's posting, or he's delivering leaflets, which is like post. Anyway, he starts and finishes from the village bus stop at A. So he's going to start at A. Determine the total distance Musab will need to walk. Okay, so how do we do this? Well, first thing is we say, is the graph an Eulerian graph? And the answer is no, because an Eulerian graph has only even vertices, whereas this one has some odd vertices. And by odd, I mean there are 3 edges along A. So A is not, let me make this a little bit bigger. A is not an even vertex. Okay, so what we need to do, and guys, if you don't know, if you don't understand how to do this, and you don't understand what I'm doing here, go back and watch my Chinese postman video. It explains it better. So we have we have some odd vertices. So let's actually point out which those are. Odd vertices. So our odd vertices are A, B, and D, and H. And that's it. There's only 4. I think they say in the guide the maximum you can get is 4 odd vertices. Because you'll see this becomes quite complicated because we need to find out the shortest routes between all of these. So I need to look at all the different combinations. So if I have A, B, and DH, because essentially what I need to do is I need to connect the odd ones to each other to create an even vertices. For example, if I join A to B like that, now I have A is an even vertex and B is an even vertex. And if I can do that for D and H, I will get an Eulerian graph, and then I can just add up the numbers. So that's the goal here. So A, B, and DH. Let's just write them all out here. A, B, and DH. Then I could have A, D, and BH. Or I could have A, H, and BD. So that's the 3 different combinations. There are no other ones because I need to join 2 together. So there's only 3. It's either this, this, or this. But to find out which one to choose, I need to find what's the shortest, which is the shortest of these 3. So A to B is 56. This is the weight. A to B is 56, and D to H, well, it's either 31 plus 20, which is 51, or 16 plus 27, which is 43. So it's actually this one. 16 plus 27 is 43. So it's 56 plus 43, which is 99. Okay, now let's look at AD and BH. AD is 19, and BH it's going to be this way. It's going to be 19 plus 27, which is 56. 19 plus 56 is 75. Now, guys, you may think, right, it's definitely going to be this one, but that's not good enough. You have to show it. You have to show the next one as well. And it might be this. Who knows? A to H, right? So to get from A to H, it's either 49 plus 20, which is 69, or this way is arguably quicker, which would be 19 plus 16 is 35, plus 27 is 35, 45, 55, 62. No, this is quicker. 62. So it'd be 62 plus, and then the BD is 19 plus 16, which is 35. This is equal to 97. So yeah, I was right. It is this one. It's AD and BH. So I'm going to join A to D, like this. And I need to add in 19 here. And I'm going to join B to H like this by 56. So B to H, and I'm going to do I'm going to do B to E, which is 19. And then E to H, which is 27. So I'm basically adding up everything, but I'm going to add on a 19 again. So there'll be two of these 19s, and I'm going to add on an extra 19 and an extra 27. So now I just essentially need to add up all these numbers. So total distance, well, I'm going to actually write down here, use A, D, and BH. Use AD and BH. Yes, show the diagram as well. So this is all good working. And then I can just do total distance. And I have to basically add up all these numbers now. This, guys, if ever there's an easy way to make a mistake, it's here. So I'm going to, well, I don't know what I'm going to do. Let me just, okay. Let's do 56 plus 42, 56 plus 42 plus 31 plus 44. And I'm just going around the outside first, plus 21. I literally just have to add up all these numbers that I see and not make a mistake. If you have when you're doing it in an exam, just cross off the numbers as you write them down. But it's a little bit hard for me to do it this. Anyway, plus 38, hopefully I won't make a mistake, plus 36, plus 49. Okay, now I'm going to go into the inside one, so I'm going to do plus 19, plus 19 again, plus 31, plus 20, plus 27, plus 27 again, plus 16, plus 19, plus 19, plus that 10, plus the 50, plus the 26, plus the 27, and plus the 20 that I didn't add in that other 20 down here. Okay, I think I did that right, please, because if I didn't, I'll have to do this whole video again. Anyway, let's press return. 647. I need to check the mark scheme, but hopefully that's right. Always check the mark scheme, guys, remember. All right, so your total distance is 647. Okay, great. Then B, explain which junctions, instead of having to catch the bus to the village, Musab's sister offers to drop him off at any junction and pick him up at any other junction of his choice. Explain which junction Musab should choose as his starting and finishing points. Okay, so essentially, he doesn't have to do this thing again. He doesn't have to kind of go back on walk the same route twice. He can start. Let me get rid of these blue lines. Actually, let me keep them, sorry. He can start now in one of the odd vertices. So imagine he starts at, imagine the blue lines weren't there, and he starts at B. So now he could start at B and finish at H, or he could start at A and finish at D. So he can start at one of the odd ones and finish at one of the other odd ones, and he'd still be able to go along every single path. So which should he choose as his starting and finishing points? So essentially, actually I will get rid of these guys. I'll get rid of this and this and this. Right, so he basically needs now to connect two. He should either connect A and B, or A and D, or A and H, or B and D, or B and H, or D and H. So the pairs, he just needs to connect two to each other just once, and then he'll have two odd, because look, let me do that again. if I connect A to B, now I just have, they're all even. They're all even vertices except D and H. So now we'd start at D and finish in H. Similarly, if we connected, let's say D to H, now they're all even except A and B. So we just need to decide which will we connect. Will we connect AB? Let me move down a bit here. Will I connect AB, AD, AH, BD, BH, or DH? And essentially I want to connect the shortest one. So AB is 56, AD is 19, AH is this 35 plus 27 is 62. My BD is 35. My BH is 19 plus 27 is 46. And my DH is 43. So this one is the smallest. So I'm going to connect A to D. So I'll connect A and D here. So if they're connected, the question says, which junctions should he start and finish? So he should start and finish at the other two odd ones, which are B and H. B and H. And it doesn't matter which. He could start at B and finish at H, or he could start at H and finish at B. Okay, that's it, finished.